The forum is appropriate for discussing industry events like the NECA show. Several users have expressed interest in attending the NECA show in Boston from October 8th to 11th. One user plans to attend the NECA show and is particularly interested in the sessions on electrical safety and new technologies. Another user will be at the show with a few colleagues and is hoping to connect with vendors and learn about the latest industry trends. A user is a first-time attendee and is excited to see what the NECA show has to offer. In addition to those mentioned, many other users may also be planning to attend, but have not yet announced their plans on the forum. Electrical safety is a crucial aspect of the electrical industry, encompassing a wide range of practices and standards designed to protect individuals from electrical hazards. These hazards can include electric shock, arc flash, and fires caused by faulty wiring or equipment. Several organizations and standards bodies such as the National Electrical Code, or NEC, and the Occupational Safety and Health Administration, or OSHA, play a significant role in establishing and enforcing electrical safety regulations. The NEC, published by the National Fire Protection Association, or NFPA, provides comprehensive guidelines for the safe installation of electrical wiring and equipment. It covers various aspects, including wiring methods, overcurrent protection, grounding, and equipment installation. The NECA is updated every 3 years to reflect the latest advancements in technology and safety practices. OSHA is responsible for ensuring safe and healthful working conditions for employees. OSHA's electrical safety standards cover a wide range of workplaces, including construction sites, manufacturing facilities, and general industry settings. These standards address topics such as lockout-tagout procedures, personal protective equipment, and safe work practices for electrical work. One of the most important aspects of electrical safety is proper grounding. Grounding provides a low-resistance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and de-energize the circuit. This reduces the risk of electric shock and equipment damage. Grounding systems must be properly designed and installed to ensure their effectiveness. Another critical element of electrical safety is overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. This prevents overheating and potential fires. Overcurrent protection devices must be properly sized and installed to protect the electrical system. Arc flash is a dangerous phenomenon that can occur when a high-voltage electrical fault creates a sudden release of energy in the form of heat and light. Arc flashes can cause severe burns, blindness, and even death. To protect workers from arc flash hazards, employers must conduct arc flash hazard assessments and implement appropriate safety measures, such as wearing personal protective equipment, or PPE, and using insulated tools. Lockout-tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the equipment from its energy source and applying a lock and tag to prevent it from being turned on. Lockout-tagout procedures must be followed diligently to ensure the safety of workers. New technologies are constantly emerging in the electrical industry, offering the potential to improve efficiency, reliability, and safety. These technologies include smart grids, renewable energy sources, and advanced metering infrastructure, or OMI. Smart grids use advanced communication and control technologies to optimize the distribution of electricity. They can improve grid reliability, reduce energy waste, and enable the integration of renewable energy sources. Renewable energy sources, such as solar and wind power, are becoming increasingly important as the world transitions to a cleaner energy future. These sources offer a sustainable alternative to fossil fuels and can help to reduce greenhouse gas emissions. AMI uses advanced metering technology to collect and transmit data about energy consumption. This data can be used to improve energy efficiency, detect outages, and provide customers with more information about their energy usage. Industry trends are constantly evolving, driven by factors such as technological advancements, changing regulations, and increasing demand for energy efficiency. One major trend is the growing adoption of energy-efficient technologies. These technologies include LED lighting, high-efficiency motors, and variable frequency drives, or VFDs. LED lighting is significantly more energy efficient than traditional incandescent lighting, and it also has a longer lifespan. High-efficiency motors use less energy to perform the same amount of work as standard motors. VFD allow motors to operate at variable speeds, which can save energy in applications where the load varies over time. Another important trend is the increasing focus on sustainability. Companies are looking for ways to reduce their environmental impact and improve their bottom line. This includes investing in renewable energy sources, implementing energy-efficient practices, and reducing waste. The electrical industry is also becoming more data-driven. With the advent of smart grids and AMI, vast amounts of data are being generated about energy consumption and grid performance. This data can be used to improve grid reliability, optimize energy usage, and develop new products and services. Connecting with vendors is an important part of attending industry events like the NECA show. Vendors can provide valuable information about the latest products and services, and they can also offer solutions to specific challenges. When connecting with vendors, it is important to be prepared with specific questions and to have a clear understanding of your needs. Be sure to ask about product specifications, pricing, and warranty information. It is also helpful to network with other attendees and share information about vendors and products. Networking can provide valuable insights and help you to make informed decisions. Learning about the latest industry trends is another key benefit of attending industry events. These events provide a platform for experts to share their knowledge and insights, and they also offer opportunities to see new products and technologies firsthand. By staying up to date on the latest trends, you can make informed decisions about your business and stay ahead of the competition. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a broad range of electrical topics, aiming to protect people and property from electrical hazards. Article 90. One of the NEC outlines the purpose of the code, which is the practical safeguarding of persons and property from hazards arising from the use of electricity. The NEC is not a design specification, nor is it an instruction manual for untrained individuals. It's intended for use by qualified electrical professionals. Chapter 1 of the NEC provides general requirements for electrical installations. This includes things like wiring methods, overcurrent protection, grounding, and equipment installation. It also defines terms used throughout the code. Chapter 2 covers wiring and protection. This chapter details the requirements for various wiring methods such as conduit, cable, and raceways. It also covers overcurrent protection devices such as circuit breakers and fuses and their proper application. Chapter 3 deals with wiring methods and materials. This chapter provides specific requirements for different types of wiring methods, including their installation and support. It also covers the characteristics and uses of various wiring materials. Chapter 4 focuses on equipment for general use. This chapter covers a wide range of electrical equipment, including appliances, luminaires, motors, and transformers. It provides requirements for their installation, wiring, and protection. Chapter 5 addresses special occupancies. This chapter covers electrical installations in locations with unique hazards or requirements, such as hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment. This chapter provides requirements for specialized electrical equipment, such as electric signs, electric welders, and electric elevators. Chapter 7 deals with special conditions. This chapter addresses electrical installations under unusual circumstances such as emergency systems, fire alarm systems, and critical operations power systems. Chapter 8 focuses on communications systems. This chapter covers the installation of communication wiring such as telephone, data, and cable television systems. Chapter 9 contains tables and annexes. This chapter includes tables providing information on conductor ampacity, conduit fill, and other technical data. It also includes annexes providing additional guidance and information. The NEC is a complex and comprehensive document, and it's essential for electrical professionals to have a thorough understanding of its requirements. Proper application of the NEC is critical for ensuring the safety of electrical installations. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. The electrical professional should stay up to date on the latest edition of the NEC to ensure compliance with current standards. Grounding and bonding are critical aspects of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects non-current carrying metal parts to create a low impedance path for fault current. This helps to prevent electric shock and reduce the risk of fire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a safe level, preventing overheating and potential fires. Arc flash is a dangerous phenomenon that can occur when a high-voltage electrical fault creates a sudden release of energy in the form of heat and light. Arc flash can cause severe burns, blindness, and even death. Personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair work. These procedures involve isolating the equipment from its energy source and applying a lock and tag to prevent it from being turned on. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Training should cover topics such as grounding, bonding, overcurrent protection, arc flash, and lockout-tagout procedures. Regular inspections of electrical equipment and systems are important for identifying potential hazards and ensuring that they are properly maintained. Inspections should be conducted by qualified electrical professionals. The NEC provides detailed requirements for the safe installation and maintenance of electrical systems. Adhering to the NEC is essential for protecting people and property from electrical hazards. Several organizations offer electrical safety training programs. These programs can help workers to understand electrical hazards and learn how to work safely around electricity. New technologies are constantly being developed to improve electrical safety. These technologies include arc flash relays, ground fault circuit interrupters, or GFCIs, and surge protective devices, or SPDs. Arc flash relays can detect arc flashes and quickly de-energize the circuit, reducing the severity of the arc flash hazard. GFCIs can detect ground faults and quickly interrupt the flow of current, preventing electric shock. SPD can protect electrical equipment from voltage surges, which can damage sensitive electronics. Electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the hazards and take steps to protect themselves and others. By following safe work practices and adhering to electrical codes and standards, we can create a safer environment for everyone.